All right, here we go. Next level. Velocity time graphs. Here we go. All right. So remember the first thing I think, or one of the first few things I said in the last video was the y tells you why. Okay, this is huge. The y tells you why. The x-axis in both these graphs are going to be time. And time is the x-axis, goes to the right. Time doesn't stop. So time is always going to continue, okay? But now here in this scenario, we're now analyzing velocity time graphs where we're analyzing the change in velocity in a given amount of time, which gives us acceleration. Now keep in mind, velocity equals displacement over time. We know velocity is a vector quantity which involves magnitude, size, and direction. And we know it's a change in velocity over time. And a little preview with this, I'll give you a little preview for the next chapter with Newton's laws. Forces occur when acceleration occurs. Forces are caused by acceleration. You're going to need to know that. In fact, I'll give you a preview to this huge song, right? For next chapter, it goes like this. Acceleration, unbalanced, speed up, slow down, change direction. Every time, inertia. First word of that song is acceleration. Acceleration causes unbalanced forces, a net force. That's next chapter. But right now, let's talk about the change in velocity, the delta V, vector quantity, in a given amount of time, okay? So let's take a look here. Now this is hard. I'm going to start off with a hard diagram, okay? This is really hard. Because not only are you working in the top right positive quadrant, we're also working in the bottom negative quadrant. Okay, so you're really going to have to take your time and follow with this, okay? We've been doing this now a couple of years. We're getting better at, teaching this to you 8th graders. Okay, so right now you got line A, B, C, D, E. Here's what I want you to do, okay? We're going to really talk about scalar vector. Acceleration is vector because it's the change in velocity. So let's break velocity down into two components. And I'm going to make a little data table. Make a line down there. And a line down here. Okay? Now velocity is speed in a given direction. So the first thing we need to think about with acceleration in graphs is there a change in speed? So that's going to be your first column. Okay? Second, what direction are we traveling? What direction? So this right here, speed and direction, change in speed in a given direction, will tell us what type of acceleration we're encountering. And you're going to go crazy when I say some of these. Positive, negative acceleration. Acceleration, 3 criteria for acceleration. There's 3 criteria: speeding up, slowing down, and changing direction. Okay? We're going to address some misconceptions with this, so pay attention. We're going to do a graph. Alright, so now you have this. Now, let's move up. Let's take a look at line A. Here's line A. The first thing you say to yourself is this. We know it's time. To analyze the graph, the y tells you why. Say it now. The y tells you why. The y tells you what's going on. So let's take a look at this. This right here, I don't put it in green. It's a horizontal line. So here's the biggest misconception. When I throw at you velocity time, position time graphs, kids see a horizontal line. Automatically they think stop. And I'll say that doesn't necessarily mean stop. The y tells you why. We have tangible velocity right here. There is let's make up an easy number. Let's say this number is 10. This object is moving at 10 meters per second in the positive direction. You see how that works right there? Whereas before position time, if this was position, if it was horizontal, it'd stop because we're not changing position. Here we're analyzing changing velocity. The y tells you why. Look at the y-axis. Okay, so looking at that, okay, so I got the number 10 right here. Object A is going at a constant velocity, okay, in the positive direction because we're in that top quadrant. So let's fill in the data. Is there a change in speed? Is there a change in speed right here? Does A show a change in speed? So no, you write 0. Okay? No change in speed. Positive direction, it's in the positive quadrant up top. Okay? What's the acceleration? There's no change in speed. It's in the positive direction going at constant velocity. Acceleration is 0. So line A shows a constant velocity, no acceleration. Okay, that's the first one. So let's take a look at letter B. Where's B? Oh boy. Now this is a little hard. We're going to break this up a little bit. Here's segment 1 of B, and here's segment 2. It goes in both the negative and positive quadrant. So you're going to have to show two segments right here. So watch what I do here. Watch this. This is as hard as it gets. Line B. We're going to break this up to segment 1 and 2. 1 and 2. 1 and 2. Okay? So let's look at part 1. And we'll show you where part 1 is. Look at where we start. Right here we're going to call part 1. This right here. Here's B. So here's 1. And here's part 2. Okay. Is there a change in speed? Yes. Now, this is velocity. So let's take a look at part 1. Where is it at? Positive or negative quadrant? It's in the part 1 negative quadrant. So right now I'm going to write down negative. Okay, now watch this. So we have the direction part. What about the scalar part, the speed? Going this way, down here. Let's say I'm at the number 5. I'm going down to 0. What am I doing? Speeding up or slowing down for segment 1? I am slowing down. So would you call this positive change in speed or negative change in speed? I'm slowing down. My speed is decreasing. Watch this. Negative. Okay. See that right there? Negative. All right. So I'm slowing down in the negative direction. Come back to that. Let's look at our signs for part 2. Now part 2, I'm in the positive segment. I'm in the positive quadrant. Right away, I got positive direction. Okay? Positive direction. And now, think scalar, number, not velocity, think speed. Now, I'm speeding up in the positive direction. So now I've got right here, number 2. I've got a positive change in speed, speeding up. So now how do we get the acceleration? Do I have positive or negative acceleration? So watch this. I'm going to take this negative value right here. Segment 1. I'm slowing down in the negative direction. What is a negative times a negative? Positive acceleration. Slowing down the negative direction is positive acceleration? Yes. Yes, it is. See how I got that? Negative times negative is positive. Now watch this. Does segment 1 show a positive trending slope or a negative trending slope? It's sloping upwards to the right. Even though it's in this quadrant, it's a positive slope, positive acceleration. There you go. Now let's take a look at this. I was speeding up, segment 2. Speeding up in the positive direction. Easy. Positive times positive gives you positive. Just like that. How simple is that? But you have to break it down. Analyze the magnitude, analyze the direction. The scalar combined gives you vector to get acceleration. Okay, let's take a look at line C. Here's C. Hi, C. And then like a fruit drink. Oh, here's segment 1. Now let me clean this up a little bit. Do you see C? I see C. C. Here's segment 1. Here's segment 2. Right there. So now, let's look. Step by step. Come on, move up. For C. Let's look at segment 1. Segment 1. Segment 1, 2. Segment 1, 2. Segment 1, 2. So right here, segment 1 for C. Am I speeding up or slowing down? I don't care about the direction. I'm slowing down. Negative. Which direction am I in? Which quadrant? Positive quadrant, positive direction. Enough said. Because I'm in the top quadrant. Okay? Positive is top, negative is bottom. Okay, so I'm slowing down in the positive direction. Negative times positive gives you, segment 1, negative acceleration. And now let's look again, to keep it simple. This line right here is trending down to the right, showing a negative slope. Negative slope, negative acceleration. Positive slope, regardless of where it's at, positive acceleration. Positive slope, positive acceleration. Negative slope, negative acceleration. Let's analyze part 2. Now here's 1, here's 2. Look at 2 for C. It looks like the number is speeding up. We're speeding up. Bottom quadrant, negative direction. Speeding up in the negative direction. So here, let's tell a story. We're slowing down in the positive direction. Then we are speeding up in the negative direction. So let's analyze this data, write it down. So now in line C, the second part, we're speeding up, negative direction. Positive times negative gives you a negative. Again, negative acceleration. And if you can look back up again, we're trending downward to the right, showing a negative slope. So therefore, negative slope, negative acceleration. Notice I keep saying that. Just by looking at this. Negative slope, segment 1, negative acceleration. Negative slope, negative acceleration. Positive slope, positive acceleration. Positive slope, positive acceleration. This piece right here, negative slope, negative acceleration. We'll come back to that in a minute. Next part, line D, okay? What's D doing? Oh, here we go. Line D, segment 1, segment 2. Segment 1 for line D. Is it speeding up or slowing down? First off, what quadrant? Direction, negative. So watch this, for 1 and 2 here, I'll even put a 1 and 2 right here. 1, 2, here, I'll even like break it up. 1, 2, 1, 2. We're in the negative direction, okay? We'll go a little faster. Here, negative direction. Whoa, negative direction. Whoa, get up there. Negative direction. What's happening to the scalar quantity of speed? Is that scalar quantity increasing or decreasing? Well, it's Mr. Parcell. It's going -5, -10, -15. Number line, We already took into account the direction, which is negative. I care about the value, the magnitude. We're going from 5, 10, 15 in the negative direction. So we're speeding up. So look here. Segment 1, speeding up in the negative direction. Segment 2, the Y tells you why. Am I moving? Yes, I am. There is a tangible quantity of velocity. I'm going 10 in the negative direction. I'm going 10 meters per second in the negative direction. 10 meters per second, negative direction. Okay? So I sped up to here, now I'm constant velocity. Which we now know is, look here, there is no change in speed, 0. So segment 1, positive, speeding up, negative direction, negative acceleration. No change in speed, bam, constant velocity. Negative direction, 0, constant velocity. Letter E. Oh, again, here we go. A and E look just alike except for one thing. Both show no change in speed. They both show a constant velocity. A is showing constant velocity in the positive direction. I'm going a positive 10 meters per second. 10 in the positive right direction. Constant velocity. Here, I'm going 10. Here, I'll move it in there. Watch this. Here, I'll make it easy for you. It's a negative 10. 10 in the negative direction. So line E, am I speeding up? There is no 1 and 2. No. Don't care. Negative. 0 times negative. No acceleration. Okay? That's pretty hard, but very doable. And you can do it. And you're going to have to. And you can do it. I promise. Easy.